Hello everyone, hope you're all doing well. Thank you so much for watching my videos. In this video series where we are talking about machine learning foundations, we are going to talk something about the notations used in the machine learning. We have been talking about various methods, how machine learning or the computer learns to predict the future. However, before going forward, I thought we should talk something about the notations which are being used, because going forward we will be using more formulas and mathematics. But don't worry, we will take it step by step. So I thought this will be a good place where we can talk about some notations which we will be using going forward in the upcoming videos. Let's jump into the video. First, we'll talk about the number family. I think you are very familiar, and this is very basic maths, where we have something called the real numbers. Okay, we have the notation where we have, it's not a simple R. If you can see, you have an R plus and an RD. But if you see the R, it's not a simple R, it's kind of a double R. You know, it's written like this. So it's something like this. So this is all the real numbers which are available. So if this R denotes all the real numbers, that is minus infinity to plus infinity. So there is all real numbers. Example, we have minus 5, 0, 3.7, 100.2. Everything comes in the real numbers. Second one is R plus. You have a plus sign here, which is just mentions it is only the positive real numbers. If you see here, it is minus infinity to plus infinity. Here it is only 0 to plus infinity. So these are all the positive real numbers, only on the positive side. You have a minus 5 here, which you don't have. So it is all the positive numbers. And the third one, RD, if you put a R and then you put a D on top. So this D denotes the dimensions. So how many dimensions you have for the vector. For example, in this case, as there are three numbers, this is a three-dimensional vector. Okay, we have seen vectors in the past, how it is just a row of an Excel sheet, right? So that's what we have seen. What is a vector? Don't get flabbergasted by the word vector. Vector is basically a row of a data. Okay, if the row has 3 columns, then the vector has 3 dimensions. If the row has 8 columns, then the vector has 8 dimensions. Okay, here it is 3 dimensions. So you have the X, Y, and the Z direction. So R3, it is how this is denoted, R to the power of 3, and you have 3 items. So 3 is the maybe number of rooms, 9 is the area, and 1.9 is the distance, something like that. One house with 3 features. So R is any real number, minus infinity to plus infinity. Examples, you have minus 5, 0, 3.7, 100.2. R plus, this is a plus sign, only positive real numbers. Examples, 0.5, 0.15, 99.9. And RD, a list of D real numbers, that is a vector. R3 is 3, 9, and 1.9, which represents one house. Reading any vector, how do you read? We will need to deal with many vectors in our machine learning going forward. So we will need to understand how we read any vector. X is always the whole vector, which is denoted by this. You have a list and you have 3 items here. So this is a 3-dimensional vector. Xj is the jth feature of one data point. What I mean is, for example, if you have X, so the subscript J represent one item of the vector. Okay, for example, X1 is 3. This 3 denotes this item, and 9 denotes second one, and 1.9 denotes the third one. So X2, X3. So this is the index, it is 1, 2, 3. It is not 0, 1, 2 as we have been learning in Python. It is 1, 2, 3. X1, X2, X3. X1 is the first item, X2 is the second one, and third X3 is the distance. And this was about the subscript. Now going to the superscript. Superscript is basically the which vector we are talking about. For example, if we have hundreds of items, okay, each item, if I tell you 6 to the power of 50. That means we are talking about the 50th vector. Okay, so x1, x2 up to x9, that is the n data points. Now, if we combine both this and this, so xij, that is row I, that is the xij is the row I is the this one, the superscript, and column j is the subscript. So this is third. So if I put 3 here, so that's what I have written here, x to the power 2 to the base 3. So that means that is equal to 2.1. So that is the third item of the second vector. Okay, so this is the distance of the house 2. So if we can show in this diagram, which I have tried to explain it better, x is the whole vector, x1 jth feature, that is x1 is the rooms, x2 is the area, and x3 is the distance. Okay, that is the third feature of the vector. Subscript is the feature, superscript is the whole data vector. If you have many points like this, we're talking about 4 points here, or rather 3 points here. So if you have this one x1, x2 and x3, if I have to pick up the second one here, third item of the second one, so we are talking about the second entry here. So this is the second entry and x3 is the third feature of the second entry. Okay, so x1 is the house 1, x2 is the house 2, and x3, it should be 3 here in the superscript, x3 is the house. Okay, and length of the vector, what we have here is square root of the first feature, second feature, third feature, individual squares, and then square root of the whole sum. You will get the length of the vector. Okay, so what we have shown in the diagram, this is the first feature, second feature, third feature, and this is the final vector, and the length of this is given by this formula. Got it? And we have one more function which we use it very frequently, that is the indicator function, which is denoted by just a 1 and a dot. So 1, this is how it is written, 1 condition, 1 if condition is true, 0 if condition is false. So 1, you write exactly like this, you write the number 1 and then within bracket you write the condition. Here if you can see 1, 2 is even is equal to 1, so that is true, so that is why it is 1. 1, 2 is odd, so this is a condition which is false, this off. So if f of x is not equal to y, then it is 1. If bottle got it wrong, so the condition is f of x is not equal to y. So we'll just see it here. 2 is even 1, 2 is odd 0. If f of x is not equal to y, what is f of x? F of x is derived by the model for a data point, and y is actually the observed value for the data point. Okay, so if f of x is not equal to y, that means what is derived by the model is not matching the actual value, then we call it 1. So if model got it wrong, then we have it 1 because the condition is not equal. Okay, you understand that. If condition is equal, then this would have been 0. And if it is not matching, then it would have been 0. But in this case, it is not matching and the condition is the same, so it is 1. So if condition is matching, then in this case it will become 0. So why are you using it in the reverse model, reverse way? Because we want to find out how many instances where the model actually got it wrong, so that we can find the average. This feature, why we have put it in the reverse order? Because we use it in the classification of loss. Loss is equal to 1 by n. Sigma is the summation 1, which the function which we told. Inside f of xi is not equal to y. Now you understand, for every row where the derived figure is not matching the actual value for that data entry, we add a 1. So we keep on adding these ones and divide by the number of items. Okay, so you will get the average number of loss where the model has got the values wrong. So fraction of data points the model got wrong, we can get using this formula. So I think you are clear. So if the function gets it wrong, Then we add 1 for finding out the classification loss. That completes a short video on the maths notation which used in the machine learning course we will be using in the upcoming videos. Thank you so much for watching this video. I'll meet you in the next one. Thank you so much. Take care. Bye-bye.